explain the extraction of copper from its ores. So we shall look at the ores of copper, then also look at its extraction from one of the ores. So let's go straight to copper. What do we know about copper? Let's first share. What do we know about copper? Because I know copper, it's not something new. What do we know about it? Yes, Margaret. Margaret. Margaret.
Copper is a metal.
Copper is a metal. Thank you. So someone has said that copper is a metal. Let me write it here so that people don't repeat it. Copper is a metal. Yes, that is number one. What else do we know about copper? Anything that you know about copper? Anything? Alvin?
Copper does not transfer electricity.
Copper does not transfer electricity. So we say it doesn't.
Yeah.
It doesn't transfer. Or we can say it doesn't conduct electricity. That is according to you. I'm putting a disclaimer. So Alvin is saying that. Alvin is saying that copper doesn't conduct electricity, but I want someone to second it. Before we get a third point, I want someone to second Alvin's point. Virunji, are you seconding it? How many say that copper doesn't conduct electricity? You can just raise up your hand, or you can say yes. If you have an updated version of Zoom, then you have that option under reactions to say yes or no. So how many say that copper doesn't conduct electricity? Maybe we can use our hands, we can raise up our hands. Or you can say, okay, I think there is also that option under reactions. A thumbs up. So how many say it conducts electricity? I need like 10 people. So 1. So we have 4. Alright, thank you. So Alvin, what you're saying is that copper doesn't conduct electricity, but that is wrong. Our members here are saying that it is wrong, and very, very wrong. Because if you look at most of the wires we use for electricity, most of them are made of copper. So copper conducts electricity, so to clear the air, so that if someone comes in later and he or she doesn't know where we have reached, can know that copper conducts electricity, and it is one of the common conductors of electricity that we use. Another point, number 3, we did like 4 and we move on. In the chat, Eve was saying that copper conducts electricity and so on. Someone here, Claire, she's saying that it is red. She's saying it is red, brown, metallic, red, brown, metallic element. And lastly, what can we say? Let's have someone is called Chance. Yes, Chance. Chance, please, your hand is up. Okay, we can have Rebecca. Yes, Rebecca.
Yes, copper has
4 electrons on its outermost shell.
Rebecca is saying that copper has four electrons in its outermost shell. Rebecca, I don't think that is right. It has only two. But thanks for trying. Okay, so that's all. Others we can use the chart. So we can say that as we gave what we know about copper, let's look at where we can extract it. Remember, we are looking at extraction of metals, and now we want to look at extraction of copper. So we look at the principal or chief ores of copper. Those are the ones which contain copper. So one, we have what we call copper pyrites. The one we call copper iron disulphide. Then we have cuprite, which is copper 1 oxide. So this is copper 1. That's why we have a 2 here. So how does it come in like this? It means that copper is using a valency of 1. So here we have 1, and the oxide has a valency of, two. So when we switch the valencies, we get copper 2 rather copper 1 oxide. Remember, when you are writing these chemical formulas, we don't write the 1. In case you have 1, you don't write it. So that is why 1 is not part of my chemical formula. Then thirdly, we have copper 1 sulphide. So still here copper is using a valency of 1. Remember in senior 1, if you had to remember when we're looking at these elements and their valencies, we said that copper has variable valencies. In other words, it has more than one valence. That is the valency of 1 and also the valency of 2. When we go to A level with the chemistry, we shall get to know more about copper. How does it form two valencies? Then lastly, we have what we call malachite, which is alkaline copper 2 carbonate. We call it alkaline because of the presence of this copper 2, hydroxide. So amongst Veronica is saying that copper forms an oxide which is black in color. Thank you. So amongst all these ores, we have the one which is the commonest. So in case they ask you which one of these is the commonest ore that we use to extract copper, I need like 2 hands, like 2 people to respond to that. Amongst all the 4 ores, which one is the commonest? Which one do you think is the commonest? If you have read about copper, I'm seeing some hands here. We'll start with yes, Claire.
Copper pyrite.
Claire is saying copper pyrites. Thank you. Another one? Anybody else with a different answer? Let's look at. I'm looking for a gentleman. It seems gentlemen are absent. Okay, Tanya. Tanya, what do you think? It seems Tanya is unable to talk. Remember, if I give you a chance to talk, please, you do so. You do so that we don't waste any.
Sulphide.
Tanya, are unable to hear. Sorry?
Copper to
Tanya, we can't hear
sulphide.
you. Copper 2 sulphide. Here we are having copper 1 sulphide. So Tanya, for her, she's saying copper 1 sulphide. In other words, she's meaning this. So members, here let us know the commonest. The one that we usually use is copper pyrites. Copper pyrites. It is the one which is very common. Okay. So we have looked at the ores. So if they ask you, apart from copper pyrites, which other ore can we use? We can say cuprite. And remember, you should be knowing the chemical formula. We should be knowing the chemical formula. In other words, these are the names. Cuprite, this is the chemical name, and so on. So we look at extraction of copper. Extraction of copper, and we are extracting it from copper pyrites. Copper pyrites, and remember we said the chemical formula is this. You should also be knowing it. It is like this. So that is our copper pyrite, and this is the chemical formula. So we are going to do or to go through the other basic 4 stages that we had. The one that we use when we are extracting moderately reactive metals. Remember, we had 4 stages. We had concentration of the ore, we had roasting, then we had reduction of the ore, and lastly we had purification. But also we had a note saying that copper and zinc can be concentrated by a method we call froth flotation. Flotation. We shall have, if time allows, we shall watch a video about the whole thing of extracting copper. So the ore is first concentrated by the process that we call froth flotation, and then it is roasted in air to produce copper 1 sulphide. So under this we are doing 2 things. We are doing concentration of the ore, and again reduction of roasting of the ore. So here we have our ore, and then we burn it in air. And then we shall form copper 1 sulphide, then sulfur dioxide, which is a gas, this one will escape, and also iron 2 oxide. So iron 2 oxide remains. Iron 2 oxide remains as an impurity. So we need to know how we can remove iron 2 oxide. But sulfur dioxide will escape as a gas. So after roasting, we shall remain with 2 products. We shall remain with the copper 1 sulphide and also iron 2 oxide. Like I said, sulfur dioxide just escapes as a gas. I'm seeing hands. I'll attend to you. You can use the chat, please. You can use the chat. I'll be able to get your questions. Then from there, we want to remove this impurity. We want to remove this impurity of iron 2 oxide. So what do? Here we have our heading, a subheading, remove of iron 2 oxide. So the way we remove iron 2 sulphide is by adding silicon dioxide. Which is written like this, the chemical formula. Silicon dioxide. And the one we call sand. So normally these sand and they come because of getting these ores from the underground. So in the underground we have their sand. So by adding silicon dioxide and heating the mixture in absence of air. So we are heating the mixture in absence of air. Then the solid iron 2 oxide, which is the impurity. So now we can say that iron 2 oxide is an impurity in our ore. Iron 2 oxide is the impurity in our ore that we are having, copper pyrite. Tanya is asking, why am I calling copper 1 yet it is written like copper 2? Tanya, when we say copper 1, it means that like I said before, copper has a valence of 1, and here we have a sulphide which has a valency of 2. So when we switch, we shall form copper 1. In other words, the 2 that is on the sulphide comes to copper, then the 1 on copper goes to sulphide. But remember, when we have 1, we don't write it. So that's why I'm saying that it is copper 1 sulphide. If it was copper 2, that would mean that copper has a valency of 2, and also a sulphide has a valency of 2, or sulfur has a valency of 2. And if you have to remember one of the rules of writing chemical formulas, we say that if the valencies are the same, we just ignore. So it is as good as having. So this is what we call copper 2 sulphide. Copper 2 sulphide is this one. Then this one, it is copper 1. I hope, Tanya, I've answered your question. Then Peter is asking that when we are using copper 1 sulphide, does it involve roasting? Yes, it does. We are going to look at that. Roasting is there. Roasting is there. Remember, if I take you back, we are saying that the ore is first concentrated by froth flotation. So this process that we call froth flotation, it is the one we use to concentrate the ore. So when the ore is concentrated, when most of the impurities are removed from the ore, then we carry out roasting. Now remember, I said roasting, it is the same as burning in this case, and burning involves oxygen. So here in this first equation, we are having our concentrated ore. Then we roast it, that is burning it in oxygen. So we are having 2 stages taking place like in one stage, so 2 in 1. We're having the concentration or purification of the ore, and also roasting of the ore. Okay, Peter, maybe I got your question wrongly. Yes, Peter?
And teacher, like if you say roasting, when you are roasting from like copper pyrite, you get copper 1 sulphide. That's what the means that you are roasting if you're going to get that. Why don't you just start from after that? Why don't you just start copper 1 sulphide and that process?
No, okay, I get your question. Now, there is no way you can get copper 1 sulphide minus the pyrite. Remember, we are looking for copper, and this time copper is within an ore or a compound. So we are looking for the way how we can break down that ore to make sure that we reach a compound that can easily be converted into copper. So straight away we cannot get this. We cannot get copper from the copper pyrite straight away. We cannot. And again, there is no way we can get copper 1 pyrite without the ore. So that's why we need to go through the ore to get copper 1 sulphide. So I hope I hope I've answered you. So in case you send your question and I don't read it, just know that question is not, sorry to say, it is relevant, because some of you are asking which class is this, so I might not be able to answer such questions. So let's continue. So here we are looking at how we can remove the impurity of iron 2. So we are saying that to iron 2, we add silicon dioxide or sand, and we heat the mixture. So that's the mixture of silicon dioxide and iron 2 oxide in absence of air. In other words, in absence of oxygen. Okay, why do we say that in absence of air? If there is air, or if there is oxygen, and you heat iron 2 oxide, it will become iron 3 oxide. So that would be oxidation. There would be oxidation, and if it becomes iron 3 oxide, then the impurity remains. But the main aim here, we want to remove that impurity of iron 2. So that's why we are heating it in absence of air. Then there we shall form what we call a slag, which is poured off with the reaction mixture, leaving behind copper 1 sulphide, So the slag is what is formed after silicon dioxide reacting with iron 2 oxide, or the one that we call iron 2 silicate. So after removing the iron 2, maybe let me take you back. Allow me to take you back. So once again, when I come back to the first equation, I say that this gas escapes and remain with copper 1 sulphide and iron 2 oxide. So we have removed, this one has escaped, and also iron 2 oxide has been removed by the addition of silicon dioxide. So we are remaining with only copper 1. We are remaining with only copper 1 sulphide. So that's what we are continuing with. So when we remain with copper 1 sulphide, we carry out reduction. And how do we do it? We say that copper 1 sulphide is reduced to metallic copper by heating in a regulated supply of oxygen. In heating it in a regulated supply of air or oxygen. So we are now on the reduction part, and that is the equation. So you can see that here we have copper 1 sulphide, which is going to be reduced by oxygen. So we form the copper. In other words, copper is losing this sulfur and forms sulfur dioxide. And once again, sulfur dioxide is a gas, so it is going to escape as well. Then we remain with the copper that we are interested in. So right now we have the metal we are extracting. But this copper that we have got is impure. And when it is impure, it means that we need to carry out purification as the last stage. So we have got our impure copper, the one we call blister copper. So we go to the purification of impure copper. After extracting it, we need to purify it to remove other impurities that might be associated with it. So we say that the metallic copper produced is impure, and another name of impure copper is blister copper. So if you are there and you call yourself blister, we are just remaining with adding there copper, and we know that you are impure. And it has to be purified. Someone is asking, how can we regulate oxygen in the lab? If we have air, if we are getting oxygen from air, then we regulate, or we control the coming in of air into the lab. If we are preparing it, let's say using hydrogen peroxide, then we reduce we reduce on the concentration of hydrogen peroxide. But what we are looking at is a big process. It is not a laboratory reaction or process. It's a large scale process. So every large scale process, it has what we call regulators. So they have such machines that can regulate the incoming or the outgoing of some chemicals that are used. So we said that purification of the copper is done by electrolysis. Purification of the copper is done by electrolysis. So here we are purifying the copper that we have already extracted. And this is the symbol of copper. The symbol of copper is Cu. You might find that people there were wondering what is Cu. So copper, the symbol is Cu. Capital C, small u. So let's look at purification of the purification of copper. So we have this electrolysis experiment. So what we do, we shall require two things. In electrolysis, we always need what we call electrolyte. That's the one that is going to decompose when current is passed through it. Then we need electrodes, whereby an electrode, one must be positive, another one must be negative. The one which is positive, we call it anode. The one which is negative, we call it cathode. And also need the source of current or the source of electricity, depending on what you are doing. So we have here, this is a battery. This is a battery. And where we see this positive, the positive is coming like this. So in other words, this is the positive. This is the positive. It is from the positive then to the negative, yes. So this is the positive. Then this is the negative. I think I'm doing the reverse. So this is the positive from here. Then this is the let me rub it. This is the cathode, which is the negative. Okay, so we have impure copper here, the one we have just extracted. We put it on the anode. Then the pure strip of copper. So we can get any other pure copper from somewhere, as long as it is pure. Then we use it as the cathode. So here we are saying that impurities like metals below copper in reactivity series, so for them they remain as impurities. The ones we are having here, for them they remain as impurities. They will not form ions. In case maybe you fail to get what I'm saying, we are looking at electrolysis, which is a full topic. So here I'm saying that impurities, these are metals which are under copper. If you have to look at the reactivity series, there is where we have hydrogen, then we have copper, then we have, I think we have like silver, we have gold, and I think around here we have like mercury. Yes. So these ones, they don't form ions, or they don't dissolve in a solution in the electrolyte. So for them, they settle at the bottom. And that's why we are seeing them here. The ones which are above copper, the likes of zinc, the likes of maybe aluminium, for them they will form ions. They will dissolve in this solution, in this copper 2 sulfate. Remember, we are calling copper 2 sulfate the electrolyte, like I said. So that is the structure, or that's the diagram of what will happen. So we've said that bar or blister is made the anode, and a strip of pure copper serves as the cathode. We looked at that. Then the electrolyte is acidified solution of copper 2 sulfate. That is our electrolyte. Then during electrolysis, pure copper is transferred from the impure copper anode to pure copper cathode. So from here, I want us to share a video of the purification of copper. I wanted to share the video of purification of copper so that some of the things can be clear. I know might be having there people who have not yet covered electrolysis, so they are likely not to be understanding. So let's watch a video. So we are going to share a video here, and you pay attention and you take some notes where possible. So this is our video. Like I said, you can take notes and as the video plays so that you don't forget. In case you don't hear, you just send me a message. Just send me a message through the chat.
In this video, we are going to learn how copper is purified using electrolysis. Copper metal is extracted from its ore by smelting, but it is not pure enough to be used as an electrical conductor. As a result, it needs to be purified using a process called electrolysis. Electrolysis uses electrical energy to bring about changes where the electrolyte, a solution of copper sulphate, is in contact with a pure copper sheet and an impure copper sheet. The process starts once a direct current is used to make a circuit. It is very energy intensive. There are two parts, the cathode and the anode. The pure copper sheet is placed at the cathode and the impure copper sheet is placed at the anode. What ions do you think are present in the copper sulphate electrolyte? The answer is that copper 2+ ions are present in the electrolyte along with sulphate ions. And it's the copper 2+ ions that will move between the anode and the cathode, allowing oxidation and reduction to occur. At the cathode, copper 2 ions are deposited as copper, as shown in the equation. As this happens, what do you notice happens to the size of the strip? Pause and continue when ready. The answer is that you should notice the cathode strip getting larger because pure copper metal is being deposited at the cathode. Did you get it right? At the anode, copper metal goes into solution as copper 2 ions. Deposited at the cathode, copper ion goes into anode. Solution effectively stays. What do you notice happens to the anode? Pause the video and continue when you're ready. Notice that the anode appears and sludge is left at the bottom of the reaction vessel. Here's a challenge. Why do you think that industries might not throw away the anode sludge immediately? Remember, the copper strip at the anode is impure. Pause the video and continue when you're ready. Any metal you find in the impure anode, which is below copper in the electrochemical series, doesn't go into solution as ions. It stays as a metal and falls to the bottom of the cell as an anode sludge, together with any unreactive material left over from the ore. Now the anode sludge may contain valuable metals such as silver and gold. Metals above copper in the electrochemical series like zinc will form ions at the anode and dissolve into solution. The copper sulphate solution has to be replaced if the concentration of zinc ions becomes too high. In summary, copper is purified by electrolysis, an energy-intensive process. A direct current is passed through a cell containing an electrolyte, an impure sheet of copper at the anode, and a pure sheet at the cathode. Oxidation and reduction processes lead to copper being transferred through the electrolyte to the pure copper sheet, which grows in size. The impure sheet appears to disappear and leave behind anode sludge.
So that was the video. So I'm going to play it for the last time so that those who missed something can have it.
In this video, we are going to learn how copper is purified using electrolysis. Copper metal is extracted from its ore by smelting, but it is not pure enough to be used as an electrical conductor. As a result, it needs to be purified using a process called electrolysis. Electrolysis uses electrical energy to bring about changes where the electrolyte, a solution of copper sulphate, is in contact with a pure copper sheet and an impure copper sheet. The process starts once a direct current is used to make a circuit. It is very energy intensive. There are two parts, the cathode and the anode. The pure copper sheet is placed at the cathode and the impure copper sheet is placed at the anode. What ions do you think are present in the copper sulphate electrolyte? The answer is that copper 2+ ions are present in the electrolyte along with sulphate ions. And it's the copper 2+ ions that will move between the anode and the cathode, allowing oxidation and reduction to occur. At the cathode, copper 2 ions are deposited as copper, as shown in the equation. As this happens, what do you notice happens to the size of the strip? Pause and continue when ready. The answer is that you should notice the cathode strip getting larger because pure copper metal is being deposited at the cathode. Did you get it right? At the anode, copper metal goes into solution as copper 2 ions, as shown by the equation. When a copper ion is deposited at the cathode, another copper ion goes into solution at the anode. The concentration of the solution effectively stays the same. What do you notice happens to the anode? Pause the video and continue when you're ready. You should have noticed that the anode gradually disappears and sludge is left at the bottom of the reaction vessel. Here's a challenge. Why do you think that industries might not throw away the anode sludge immediately? Remember, the copper strip at the anode is impure. Pause the video and continue when you're ready. Any metal you find in the impure anode, which is below copper in the electrochemical series, doesn't go into solution as ions. It stays as a metal and falls to the bottom of the cell as an anode sludge, together with any unreactive material left over from the ore. Now the anode sludge may contain valuable metals such as silver and gold. Metals above copper in the electrochemical series like zinc will form ions at the anode and dissolve into solution. The copper sulphate solution has to be replaced if the concentration of zinc ions becomes too high. In summary, copper is purified by electrolysis, an energy-intensive process. A direct current is passed through a cell containing an electrolyte, an impure sheet of copper at the anode, and a pure sheet at the cathode. Oxidation and reduction processes lead to copper being transferred through the electrolyte to the pure copper sheet, which grows in size. The impure sheet appears to disappear and leave behind anode sludge.
Okay, so that is our purification of copper, and I hope it has been very clear to everyone. So for us who are here, so like we saw in the video, during electrolysis, the pure copper is transferred from the impure copper anode to the pure copper cathode. Therefore, the anode dissolves. The anode dissolves and decreases in size as the cathode grows bigger. So, if I'm to repeat that, it means that if you look at our diagram, this one we are saying that it will dissolve, whereby ions will keep on going this side, and eventually it will dissolve, and when it does that, it can be replaced. So those are the equations. We are saying that at the anode dissolves the impure copper. The impure copper dissolves to give us these ions. So these are the ones which are in solution. And again, after being formed, then they are transferred to the cathode. So they are these ones, which later turn into the copper solid that is pure. So this is the pure solid, pure copper solid. So that is what to do with purification of copper and extraction of copper. So if you are to explain extraction of copper, you have to explain until when you reach where copper is purified. Let's briefly look at the uses of copper. So copper is used for wiring electrical circuits, since it is a good conductor of electricity, and again it is also cheap. Copper wires are cheap. And then it is used for making ornaments like earrings, then we have pins, bangles, and so on. So we have some bangles or earrings which are made of copper. Why do we use copper? It is because apart from being cheap, it doesn't react. Its reactivity with air is minimal. The reactivity with copper is minimal. In other words, it doesn't wear off very easily. In other times, you can buy like a pang and you see it reducing in size. It is always because of the reaction of maybe that metal with air or with anything where you use it. So when you have a bangle made of copper or an earring, it can wear off, but it takes time. Then it is used for making alloys like bronze, brass, copper coinage, German silver, and so on. So we looked at alloys in senior 1. So copper is used to make some alloys, but the common ones that we know are bronze and brass. Then copper is used for water pipes making water pipes and boilers because it's a good conductor of heat. And lastly, copper is used as a roofing material. It is also because of its low reactivity with air and water. Otherwise, if it was reacting very easily with the water or air, then the roof or the iron sheet would wear off also very fast. So we use copper so that the roofing or the iron sheet can take longer. So that is the end of our lesson, and we still have 10 minutes. Maybe we can use those ones for questions. So if you have any questions, please raise up your hand. Any questions? So if you don't have, I think I have. So I'll be choosing at random. Someone is asking, Priska is asking, copper 1 is an ore, so if you are to roast it, what do you get? So if you use copper 1, as an ore, then straight away you roast it in air. Yes, Marunji?
Yes, teacher.
Yes, please. Yes, please.
Copper refining carried out.
I beg your pardon?
How is carried out? How is copper refining carried out?
It is the same as purification of copper, the one we've just looked at. We use electrolysis. So we can either use the word purification, or we can use refining of copper. They are the same.
Okay.
Alright. Then again, another person. Who can tell us the main ore for extraction of copper? The main ore we use for extraction of copper. We have Liam.
Copper pyrite.
Copper pyrites. Okay, thank you. Then which method do we use for concentration of the copper ore, or for the concentration of copper pyrite? Yes, Chance?
We use froth.
I beg your pardon?
Floatation.
So thank you. So we concentrate the copper ore by froth flotation. Okay. Then what do we use to purify the copper metal after being extracted? Which method do we use to purify or refine copper metal after being extracted? Annette?
Master, the method is electrolysis.
Okay, thank you. So the method is electrolysis. It seems I'm asking very simple questions. Then again, which other question? How do we remove the impurity of iron 2 oxide from the ore? How do we remove the impurity of iron 2 oxide from the ore, from copper pyrite? How do we do that? Yes, for here.
By adding silicon dioxide and heating the mixture in the absence of air.
Thank you so much. So by adding silicon dioxide, or what we call sand, and we add it to iron 2 oxide, and we heat them, or we heat the mixture in absence of air. So I don't know why there is anybody there who can write down that equation. Who can write down that equation? Then you share with us your screen. When you get done, when you get done, then you can just text me, send me a message. We have around 6 minutes remaining. Make sure you send me a message after finishing, and you also indicate whether you know how to share your screen. Then you'll be given that chance within these remaining minutes. Okay, then again, during the purification of ore, During the purification of copper metal, I hope you're clear. You're hearing me clearly. During the purification of copper metal, what do we use as the anode? What do we use as the anode? The question is, during the purification of copper metal, what do we use as the anode? What do we use as the anode? Yes, Sarah? Sarah?
Copper.
Copper? There is something missing. Yeah, it is copper, but there's something small missing. Can you make it right?
Impure copper.
Okay, thank you. We use impure copper. Priska is saying impure copper, and Shirabo is also saying impure copper. So we use impure copper as the anode. Then the cathode. What do we use as the cathode? Melissa?
We use pure copper.
We use pure copper. Thank you. And then, what do we use as the electrolyte? What do we use as the electrolyte? What do we use as the electrolyte? Yes, Shivan? Shivan? Shivan, talk to us. It seems we are unable to get to Shivan. Let's have Fancy. Fancy, you have a name. Yes, Fancy. Crystal. Fancy, you can unmute, or Crystal. Fancy, Crystal. Let's have Joel.
Copper 2 sulphate.
Copper 2 sulphate. And we called it acidified copper 2 sulphate. So if you can remember that word acidified, is better. And people are also giving me the answers in the chat. We have Priska, she's saying copper sulphate. It is supposed to be copper 2 sulphate. Because copper has 2 valencies, so if you don't indicate a valency, then it becomes wrong. So we are using copper 2 sulphate. Or we can say acidified copper 2 sulphate. Yeah, even right now I'm waiting for the message from someone to give us the equation of silicon dioxide reacting with iron, 2 oxide. Then lastly, the last question. What are the impurities? What are those impurities that remain after purification of copper? What are those impurities that remain after purifying the copper metal? Let's have Anthony. Musinguzi?
Sludge.
We call it sludge. Thank you. But within the sludge, what is there? What are those elements?
Gold and
so
silver.
We have there gold and silver. Or we said those elements which are below copper in the reactivity series. So thank you so much. I appreciate the intelligence here. It seems this is the brightest class for so far that I've seen. So I appreciate the input and the sacrifice you are making to make sure that we are here. So I want to welcome one person to give us a closing prayer. Remember, we forgot to have an opening prayer. So let's first ask God to forgive us that we forgot. So we need someone to take us through a prayer. We need someone. Can we have Crystal, are you back? Okay. Crystal? Seems Crystal, you have issues with network. Let's have Isaac. The Isaac in the Bible. Jacob's Isaac and Abraham. Isaac.
Hello.
Yes, hello.
Good afternoon, everyone. Let's humble and pray. Let's humble and pray. Heavenly Father, Jesus Christ in heaven, we thank you for this class and we apologize for not praying at the beginning of the lesson. We pray that whatever that we've studied, we get it and let it be part of us till up until the end, until we sit in the almighty name of Jesus. I have prayed. Amen.
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 So thank you everyone, and I wish you a good afternoon.
Thank you, sir.
Teacher.